Hello Techie guys, welcome back to Techie Uday. As usual, today also we are going to solve one more Leetcode problem. What is that problem and how we can solve that? Let's check it out. But before going to that, when we are solving any problem, some problems might be tagged as easy problems, but there might be some tricky parts involved to solve that problem effectively. Some problems might seem easy on the first look, but to solve it effectively or efficiently, we need to follow some optimizations in a competitive programming. Today, we are going to see one of such problem, even though it seems easy on the first look, while solving, how can we avoid repetitive computations? Okay, let's see what is the problem. This is the problem that we are going to solve today. Find resultant array after removing anagrams. What is an anagram? An anagram is a set of words where all the words forms with the same set of characters. For example, if you take two words, those two words should have the same set of characters. No two words should have a different set of characters. For example, let's see in the example below, ABBA and BABA both are anagrams because ABBA has two A's and two B's, BABA has two A's and two B's. The number of characters should same and the frequency of each character also should be same. The length also should be same because if the frequency are same, obviously the length also will match, right? So these are all called anagrams. To make it more clear, let's see this in our visualizer. Our visualizer is loaded. So we have four letters, we have five words in our input. When we take this one, and if we take this one, these two are anagrams because both has two A's and two B's. The word two has two A's and two B's. Word one has two A's and two B's. We can also check if two words are anagrams or not by sorting the words. If the sorted values of both words are same, we can say that the words are anagrams. So hope you understand what are anagrams. If you take these two, those are all not anagrams. The length is different. Obviously, the characters are also different. It has one C and one D. It has two A's and two B's. So those are not anagrams. If you take one more example, A, B, B, C, C, D, let's make it in quotations as the input, and A, B, A, B, D, C, C. If you take this example, these two values, right? Take these two values. Both are anagrams because it has two A's, two B's, two C's, and one D. Like so, both are same. All the characters are same. So both strings we call them as anagrams. So this is how we can identify whether two strings are anagrams or not. So let's go back to the problem now. So in in a zero-based index array words, we have an array of words. In one operations, if we select any index I, the I minus one word and ith word should not be the anagrams of each other. See, the words of I minus one and word of I are anagrams and delete the words of I from the words. If I minus one and word of I both are anagrams of each other, we need to delete words of I from the given input. And finally, we should return an array that doesn't have adjacent anagrams in the result. So keep perform this operation as long as you can select an index and satisfies the condition, right? We need to perform this operation selecting the index and if they are anagrams, remove the words of I repetitively till we reach the end result where no two adjacent words are anagrams of each other. So here they are defining an anagram. Anagram is a word or phrase formed by rearranging the letters of different phase. This is a bit complex. So finally it is trying to say two words or two sentences should have the same set of characters with the same frequency, same length. So that is what an anagram means. So how can we solve this problem? One way to solve this problem is a kind of brute force approach. Take the result array, it's a kind of empty value, and add the first one to the result. Then start from the second. We are selecting I. They are asking we need to select I, and I minus 1 and word of I should not be the anagrams of each other. So the first element anyhow it would be in the result in any case. Then when we select the second one, we should compare it with I minus 1. If both are anagrams, we should not do anything. Just continue. If both are not anagrams, then add the current value, word of I, to your result. For example, if we check here, these two are anagrams. So continue. We check these two, and this is I and this is I minus 1. If both are not anagrams, so we need to add the current I value, I mean CD, to our result. And finally, we select this as I, and this is our I minus 1. So these are all anagrams. So we should not do anything, and this is our final result. So this is how we can easily solve this problem, and that is the reason it is tagged as easy problem. But wait, when you are doing this problem, you are doing multiple computations, duplicate computations again and again. For example, you are adding this and you are comparing these two. You need to sort this one and also sort this value. And while comparing these two, you need to sort this value and also sort this value again. You have done this twice. And while comparing these two, you need to sort this and sorting twice. So for each and every value, you are doing the sort operation twice, which is not so efficient. Even though this problem accepts the brute force solution, but we need to think for optimized way of solving the problem. So let's see an optimized two-pointer approach for this problem, how we can solve and how we can avoid multiple sorting of the same word effectively and efficiently. So to understand that, go back to our visualizer with the given input and check. So let's take the given input. So we have two pointers, one is left and one is right. Left pointer and right pointer are initially take the value as 0 and they point to the same. Then whenever left pointer and right pointer pointing to the same word or same index, add that to the result. Whenever left and right pointers are pointing to the same index, add that word to the result and increment right by 1 and then compare. Before comparing, sort the current value and store it. Then while subsequent comparisons, do not sort the left value again and again. Use the previously computed value. So let's see the solution. Left and right are same, so add words of left to the result. So we add ABBA to result. Now move the right pointer by 1. Now both are anagrams, so continue. No need to do anything else. So now continue. Like both are anagrams, so we need to continue, not to do anything. Then CD. Both are not anagrams. ABB and CD are not anagrams. So move left pointer to the right, and now both are pointing to the same word. Both are same. So words of left is equal to CD. We add it to the result. Now CD becomes. Now increment the right by 1. So both are anagrams. So continue. We need not to do anything. We reach the end of the array. So our result is ABBA and CD. This is how we can solve this problem. Let's see another example. If we see this input in our visualizer, in the same way, let's start. Left and right are same, so add words of left to result. Result becomes A and increment right by 1. Right pointer moves. Then, yeah, we are not anagrams, so move left to the right. A becomes B and both points to the same index. So now left and right are same. So add words of left, I mean B, to our result. Then move the right pointer by 1. Then those are not anagrams. So left becomes right. Move left pointer to the right. Now both are pointing to the same. So add words of left to the result. Result becomes ABC. Then move right pointer by 1. Not anagrams. So move left to the right. and add that to the result, the same. So result becomes ABCD. Now the pointer to right. So D and E both are not anagrams. So move left to the right. So both left and right are same. So words of left to the I. The result becomes A, B, C, D and E. Now we reach the end. So the final result becomes A, B, C, D and G. So this is how we can solve this problem. Hope you enjoy, hope you understood the visualization of the solution. Let's see the code for this problem. Let's see the code for this solution. Here we have the solution we have used in the same code. Initially left and right are 0. We initialize to 0 and this is the initialized array, result array. It is empty array. While right less than the length of the words, right, the index 0 is less than the length of the words. So we are appending that word to our result. As I shown you in my previous visualization, we are appending that to the result and we are sorting the current value, left value, and storing it in a sorted word so that we should avoid the repeated computation of that value. Now I am incrementing right by 1. So if it doesn't reach the end, sorted word which is computed here, I am comparing with the words of right. Both are same. That means both are anagrams. So we should increment right by 1. We not to add anything. We should increment right by 1. We should continue the process till we found all the anagrams. So till we find all the anagrams, both sorted word and sorted of words of right same. That means all the set of words are anagrams of the first word. So we increment right by 1 subsequently. At the end, whenever we find both are not anagrams, then we make left equal to right. So we put right value in the left. Now left becomes right. Right and left value both are same. So again the loop starts. We are appending the words of left value to our result. And we are calculating the current left value sorted word and incrementing the right by 1. And we are starting the same process. And finally, we are written in the result. If you did not understand this clearly, go back and see the visualization. You will get more and more deeper understanding of this problem. Even though this seems very simple problem, it is a very basic idea for different set of problems. And this type of problems you need to solve more and more to get more versed into the problem solving. So practice more and thank you for watching this video. Have a good day. And if you have any doubts in this problem or if you want any particular problem, let me know in the comment section below. I'll make very detailed videos and with nice and easy understandable animations in my further problems. Subscribe to my channel. Let's submit this. I forgot to submit. Yep, problem submitted. Beats 100% of all the values. Like it's beat 100%. So subscribe to my channel, stay tuned, and have a good day. Thank you for watching. Bye bye.